So we're going to discuss now electronegativity. What is electronegativity? It's a measure of the atom's ability to attract electrons. It increases from left to right in the periodic table and also increases from bottom to top. The difference in electronegativity between two atoms defines the type of bond that the two atoms will have. We will have non-polar covalent, polar covalent, or ionic. As we see here, this is the trend of the electronegativity in the periodic table. The most electronegative element is fluorine. As we see, it increases in this direction and it also increases in this direction. So if two atoms have, depending on the difference in electronegativity between the atoms, we will have different type of bonds. So we need to define the type of bonds. We have non-polar covalent bonds. In this case is when we have non-metals, and also the difference in electronegativity between the atoms is between 0 and 0.4. So what we do is we look at the previous slide that we just saw, and we compare, do the highest value minus the lowest value in the electronegativity. And that difference, if it falls between 0 and 0.4, then we have a non-polar covalent bond. The other type of bond is the polar covalent, and that is when the difference in electronegativity follows between 0.5 and 1.7. For example, oxygen and chlorine. 3.5 minus 3, that gives you 0.5, that is polar covalent. You don't have to worry about memorizing the values of the electronegativity. You just have to memorize the trend. Increases in this direction and this direction in the periodic table. Based on the difference in electronegativity, we'll have what is called a dipole. A dipole is a vector that goes from the least electronegative element to the most electronegative element. And in this case, as we see in the periodic table, here is carbon, here is oxygen. By the trend, oxygen is more electronegative, therefore the dipole starts in carbon and it goes to oxygen. The last type of bond that we have is the ionic bonds. Ionic bonds occurs when we have a metal and a non-metal. The difference in electronegativity is between 1.5 and more. So based on the type of electronegativity, as a review, we have covalent non-polar, covalent polar, and ionic. And for this, we either evaluate the trend or we have to have the table with the electronegativities. So a problem like this, we see potassium is a metal, nitrogen is a non-metal, immediately we know that this is ionic. For something like this, we have nitrogen and oxygen. Nitrogen, then we look at the electronegativity table. Nitrogen's electronegativity is 3. For oxygen is 3.5, so we do 3.5 minus 3, that is 0.5. Therefore, this type of bond is a polar covalent. Let's go to the next one, chlorine-chlorine. Because it's the same two elements, therefore, we are in the presence of a non-polar covalent bond. All right, the last one, boron and chlorine. So for boron, we have an electronegativity of 2. Chlorine has an electronegativity of 3. So we do the math. 3 minus 2 is 1. So this bond is polar covalent.